172 Similarity Transformations. Example 1. If line M is represented by the equation x equals -1, what is the graph of the image r of m times d 1/2 times triangle ABC? Okay, so first thing we're going to do is create our line. And they're giving us equation x equals -1 or -3. We know that x equals -3 is going to create a line, just do it as points, right here at -3. Okay, so that's creating a line at x equals -3. Okay, so we have a reflection and we have a dilation. We want to do the dilation first, and it's dilation by 0.5. So to dilate, I'm going to take my coordinates and I would multiply by 0.5. So times 0.5, or just 0.5. So that's going to give me a prime. So I'd take half of 2 to get 1, half of 4 to get 2. Do the same thing with B. Again, my factor here is 0.5 or a half. So B prime. Half of -2 is -1. Half of 8 is 4. And then C. Again, scale factor of 0.5. So my C prime, half of 0, just 0. And half of 10 is 5. I'm going to go ahead and plot those. So A prime is 1, 2. B prime is -1, 4. And C prime is 0, 5. Okay, so I have my new image, but now I want to do the reflection across M. So I'm going to reflect this across M. So my point B prime is going to move directly across M. If I was 2 spaces away from M before, I'm still 2 spaces away on the other side. So this is B prime prime. A prime is 4 away. So it will still be 4 away. And C prime prime is 3 away. All right, so there is my final image of this transformation. All right, I'll try it. All right, the vertices of triangle XYZ are x 3, 5, y -1, 4, and z 1, 7. What is the graph of the image where we have a dilation of 2 and a transformation to -1 for our triangle? Okay, so I'm going to start with the original image. I'm going to go ahead and do that in black. So x is 3, 5. Y is -1, 4. And Z is 1, 7. All right, so the first thing we're going to do is our translation. So I'm going to come down here below. So I have my original coordinates, X, Y, Z, okay, my transformation, I add 1 to X and subtract 2 from Y. So I add 1 to X, subtract 2 from Y. Do the same thing for each of these. Oh, I did that wrong. So X prime will end up being 4, 3. Y prime 0, 2. And Z prime 2, 5. I can graph those. So 4, 3 is my X prime. 0, 2. Y prime. 2, 5. Z prime. Okay, and then after that, I want to do a dilation. Change my color for that. So dilation, and it is dilating by 2. So I'm going to multiply my X and my Y by 2, and it's the X and the Y of the prime. So I'd be multiplying 2 by the 4, and 2 by the 3, 2 by the 0, and by the 2. So X prime prime would end up 8, 6. Y prime prime 0, 4. Z prime prime 4, 10. Okay, I can graph that. 8, 6. 0, 4. Right, so that is what my final transformation would look like. Okay, so that was part A. Next we want to do part B. Take a second, make sure that you have everything copied down from A. I'm going to have to erase this so that we can work on B. So we have our original XYZ on there, still graphed. Next we want to work on B, which has a dilation of 3, but a rotation of 90 degrees about the origin. Right, and if we remember with a rotation, to find our rotation, our x, y flips and our y turns negative. So if I'm rotating by 90 degrees, my x and my y will flip and my y becomes negative. Okay, again, I will rotate first and then I will dilate. So my rotation, I have my x and my y and my z. So x, y, z, okay, I'm going to flip my x and my y, make my y negative. So this will become negative 5, 3, negative 4, negative 1, and negative 7, 1. So this is my x prime, y prime, change that to capital, y prime, z prime. I can graph those. So my x prime, y prime, and z prime. Okay, from there we want to do our dilation, and this time it's a dilation of 3, so we're going to multiply by 3. So 3 times negative 5, and 3 times 3. 3 times negative 4, 3 times negative 1, 3 times negative 7, 3 times 1. So my x prime prime will end up being negative 15, 9. Y prime prime will end up negative 2, not negative 2, negative 12, negative 3. And z prime prime will end up being negative 21, 3. I'll go ahead and plot those. Let me kind of, so this is my dilation. I'm going to plot that in red. Negative 15, 9 is my x prime prime. Negative 2, negative 3, or negative 12, negative 3 is y prime prime. Negative 21, 3 is z prime prime. Okay, so there is my transformation for part B. Example 2, is there a composition of transformation that maps XYZ to JKL? And then we need to explain. Okay, so we're not looking for just one dilation, one rotation, one transformation. We're looking for a composition of those, so several of those put together. Okay, so I can already tell that there's more than one thing happening. My pre-image is a lot smaller than my new image. So I know there's going to be a dilation in there to increase the size, to enlarge it. But I also can see that my image has to rotate to get into the same position that needs to be. So I need a rotation and then an enlargement of that. So I'm going to start with the rotation to figure out my rotation. Okay, so if I rotate about my origin, so if my origin is right here, change my color, if my origin is right here and I rotate about that, I would need to rotate 180 degrees to have my images in line. So if I rotate this 180 degrees, I'm going to end up with those points. Okay, from here, now I can dilate my image to enlarge it, to make it bigger, and to end up in the same position that it needs to be. So far we have figured out that we had a rotation of 180 degrees and then a dilation, but we need to find out what the dilation scale factor would be. So to find out my dilation scale factor, I can look at some of my coordinates. So I'll call this y prime, x prime, z prime. So if I look at L in comparison to z prime, those coordinates for L are -8, -2, z prime is -4, -1. So I can create scale factors out of that. So -8 out of -4. I'm gonna end up with a +2. I could do the same thing with the -2 over -1 to give me a scale factor of 2. So far it looks like my scale factor is going to be 2. I can test that out again with another point. So let's do J and X prime. So J is -2, -1. Oh, that was my X prime. I'll flip those. So J is -4, -2. X prime is -2, -1. So I'm going to divide the -4 by -2 to get me +2. I can check my -2 in comparison to my -1, which again I would get 2. So I have a scale factor of 2. So I know I have a dilation by 2 and a rotation of 180 degrees around my origin. So to write that out, I have a dilation of 2 and a rotation of 180 degrees about the origin, and that's going to map our triangle XYZ onto triangle JKL. Okay, our triad. Triangle XYZ can be rotated 180 degrees and then dilated by a scale factor of 2. We just figured that out. If these transformations are performed in the reverse order, are the results the same? Do you think your answer holds true for all compositions of transformations? All right, so this has 2 parts. The first part is asking us if I flipped the order of composition. So instead of having my dilation and then my rotation, I'm going to flip those. So I'd have my rotation of 180 degrees about my origin, and then I would dilate by 2. That would be for triangle XYZ. So let's see if that will work. So we do our dilation first. So I'm going to enlarge this by 2. Okay, so point 0.21 will become 0.42. So this is my x prime. 0.41 will become 0.82. I don't have enough space here. 5, 6, 7, 8. So roughly right in here for my z prime. And then y prime was 4, 1, or 1, 4, so it would become 2, 8. 6, 7, 8, 2, roughly right in here. So that would become y prime. So we have our dilation, now a rotation. And if I rotate this about my origin, it is going to end up in the exact same position. So yes, this will work. Okay, so that was the first part of the question, whether we could flip the order, reverse the order that we did those operations in. We can flip them, we can reverse those orders. The second part of the question is, do you think your answer holds for all compositions of transformations? So can I reverse the order for all transformations? Okay, and no, it does not hold true for all compositions. If I was to translate and then rotate, I would not get the same image as if I was to have rotated and then translated. So this does not hold true for all transformations. All right, similarity transformation. So similarity transformation is a composition of one or more rigid motion and dilation. A similarity transformation results in an image that is similar to the pre-image. Okay, so they're giving us two images and we need to identify how they are similar, what transformations they went through. Okay, so the first thing I want to do is create a line that I'll be able to reflect my original image across. Okay, so let me create a line that I can reflect across. So there's our line. I'm going to label that M. So now I want to reflect my image across. So my P prime. I'm going to create some perpendicular bisectors to help me find my links here. Actually, let me try that a different way. Okay, so I'm going to try to use a ruler and creating a perpendicular bisector with my line M. Okay, so 1, 2, 3, 4, 5. So my new point will end up right here. So that would be S prime. I'll have to write that in when I'm done. Perpendicular bisector for R. 4, 5, 6, 7, 8. And okay, right there. And finally Q. Okay, so I've got my 4 points for my reflection. It's S prime, R prime, Q prime. Connect those. All right, so that was my reflection. Next, I want to translate. Okay, so next I'm going to translate it, which means I would just be shifting it. So what I'm going to do is I'm going to, if I can grab a copy of it. Okay, so I'm going to try to grab my original image. Oh, no. But I don't want the background behind it, so I'm going to try to do this the best that I can. Okay. All right, so I've made a copy of all of those points, and I'm going to rotate it just a little bit. I'm going to try to keep the size. I think I already messed that up a little bit. I'm going to try to lay those. Let me try to undo the sizing. Okay. So I want to rotate it. I'm going to line up S with that H that's underneath it. Okay, so that is my translation. I have this be R prime, Q prime, P prime, and then S prime, and then I covered it up, but my H is back there behind it. So my H equals that S prime. Those are the same position, same point. From here, I would do a dilation. So all I would do would be increase the size of my PQRS prime prime. Okay, so what I did here to get my images similar is I did a reflection. So I reflected across that line M that I created. After that reflection, we did a translation. That's where I duplicated that image and I just slid it so that my S prime prime matched up with the H. And then after we do that translation, after we have our prime prime image, then we would do a dilation to increase the size so that it matched with our GKJH. So PQRS is similar to GKJH. All right, or try it. Describe a possible similarity transformation for the pair of similar figures shown, and then write a similarity statement. first thing I would want to do is translate C so that it falls onto C prime. Okay, so my C right here would be translated down onto C prime so that they were the same point. Let me see if I can create a triangle here that I would be able to translate. All right, so I have my image fairly close to what it should be, so I am going to translate C down onto C prime. Okay, so that's what my translated image would look like. Okay, from here, I would rotate my image so that AB is on AB prime. Okay, so I'm going to rotate this, try not to distort it. Okay, so it's not going to let me rotate the original image without distorting my triangle. So what I'm going to do is I'm going to duplicate this, move this one over here so I can make a clipping of it. Then I'll be able to move this one without distorting the image. Okay, so now I can move this one and I'll be able to rotate it without distorting my angles. Okay, so I'm going to rotate it around. Unfortunately, it will cover up some of my triangle. Let me make sure I can get this lined up right. That's going to be as good as we'll be able to get it on my tablet. Okay, so we have our rotated image where AB is on AB prime. Next, we want to dilate so that C prime is B. So we're dilating from C prime so that B is on B prime. Okay, so what we're gonna do, if I can get my image back, is I'm gonna dilate it. So I'm just going to stretch it here, back over this way. We're just gonna eyeball it. Okay, so that looks about right. So now it looks like that is right on top of my new image. All right, so that means that triangle ABC is similar to triangle A prime, B prime, C prime. All right, B, describe a possible similarity transformation for the pair of similar figures shown, and then write a similarity statement. Okay, so I can already see I'm going to have to do a reflection. So let me create a line to reflect across. Okay, I think that looks about right. Okay, so our first step was to reflect across And we're actually reflecting it across a perpendicular bisector. And it's the perpendicular bisector that is formed from Z prime down to Z. All right, so after we reflect, and again, I will try to create an image that we can reflect. Get my ruler. Actually go ahead and create my perpendicular bisector and make sure that my line is correct. Erase that. So from Z to Z prime. It looks like my perpendicular bisector is pretty close, so I'm just going to leave that. And then we want to create our points here. Okay, so I'm going to start with W. Right here. And then X. Right about here. And then my Y. About there. Okay, so I'm gonna make those my points here. So this was W, X, Y. All right, so we reflected across our perpendicular bisector. Let me go ahead and connect these. And my Z is still just D. Okay, and connect these. So we have reflected across our perpendicular bisector. Now we just need to do a dilation. So we would dilate from Z prime so that Y is on Y prime. And then after we've done that, then we can prove that WXYZ is similar to WXYZ prime. All right, example 4. Can the artist copy her sketch to cover an entire wall measuring 15 feet by 20 feet so that the mural is similar to her sketch? And we need to explain. All right, so the first thing I'm going to do is kind of sketch out what this would look like. So I'm going to create the wall. And then in that wall, we would have the painting. So I'm just going to put the painting down at the bottom. Okay, so our wall is 20 feet by 15 feet, and the painting is 11 inches by 14 inches. Well, we don't want feet and inches, so we're going to convert our feet into inches. So 20 feet, so 20 times 12, I would get 240 inches. And then 15 feet, 15 times 12, I would get 180 inches. Okay, from here we just want to see if our ratios would equal each other or be the same. So we're going to have our heights, 180 for the wall height, and divide it by the 11 inches that is the height of the picture. That's going to give me approximately 16.36. I'll do the same thing for the width, so 240 for the wall width divided by the 14 for the painting width. That's going to give me approximately 17.14. Well, those two are not equal, so that means that the mural will not fit. Okay, since our ratios are not equal, our mural will not fit on the wall as it is. All right, or try it. Suppose the artist cut 2 inches from the width of her sketch. How much would she need to cut from the height so she can copy the similar image to cover the wall? Okay, so they're telling us that she cut 2 inches from the width. Our width was 14, so now our width is 12. Our wall width is 240 inches. So 240 divided by the 12. Okay, so that's going to give me 20. Okay, so if I want a ratio of 20 for my height, I'm going to take my height, which is 180, and divide it by that ratio of 20 that I want to find out what my height needs to be. Okay, that's going to give me 9. So I want a height of 9. Well, right now, there's a height of 11 on the mural, and I want it to be 9, so I'm going to subtract. So I need to cut 2 from the mural. So she needs to cut 2 inches from her mural. All right, example 5, we want to write a proof that any 2 circles are similar. All right, so we're given that circle P with a radius R and circle Q with a radius of S, and we need to prove that the 2 circles are similar. Okay, so the first thing we would want to do is translate our circle P. So we would translate P onto Q. After we've translated P onto Q, then we want to find our scale factor so that we can increase the size of circle P to meet the size of circle Q. Okay, and our radius for P is R, but we want our radius to become S. Okay, so then our K, our scale factor, would equal our S divided by our R. That's going to give us our scale factor. So yes, circle P is similar to circle Q. All right, or try it. We want to write a proof that any 2 squares are similar. Okay, so first thing we want to do is write our given information. So we're going to come up with a statement for our given information. And we are writing this about two squares. So I'm going to create two squares. So given square ABC D with side lengths of R. So square, all of our sides have to be equal to each other. So all of those side lengths we're just going to name as R. And we're given a second square EFGH. But this time our side length is not R. We're going to name this one S. All right, we want to prove that square ABCD is similar to square EFGH. Okay, so we want to dilate square ABCD by our two side lengths. Okay, our scale factor would be those two side lengths divided. So scale factor is K would equal our S divided by our R. Okay, this would map square ABCD onto square EFGH. So square ABCD is similar to square EFGH.